Hey everyone, welcome back to Deterministic. I'm Brandon Conkle, and this channel is where I explore different approaches to bring more determinism to our programming and cut down on the level of chaos that we deal with day to day in production. This is my third live stream that I've done so far, covering the Rust example GraphQL API that I've been working on. I'm going to be doing a more detailed series of videos for this as I go along, but I'm still in the process of finishing up the final pieces of it. I've got this WebSocket work that I'm going to be doing tonight, finishing up the WebSocket handler that I've got hooking into Warp, which is an HTTP server framework built around Tokio. It's one of the most popular runtimes for async in the Rust ecosystem. And this WebSocket handler will accept WebSocket upgrade requests and keep track of a connection in a single threaded context. I haven't covered, or I'm not planning on covering Redis and PubSub or other approaches to PubSub for horizontal concurrency there. But this will cover kind of a naive beginning approach to it, to wiring it in WebSockets, a full duplex WebSocket to this GraphQL API. So there's a difference between the full duplex kind of event-driven WebSocket connection that I'm talking about here and something more like a GraphQL subscription that you would typically see on a GraphQL, especially in like the Apollo ecosystem or something like that. Whereas a subscription is more like push eventing. You can push from the server to the client. The full duplex kind of WebSocket connections that I'm talking about kind of serve more complex use cases. You can do more with them by being able to push events to the server also. It can power real-time experiences like chat and things like that. And so I found WebSockets to be a really powerful way to manage more complex kind of event-driven user interactions, something that more akin to an app than a web page, or something that would help power maybe a game or a chat platform or something like that. So where I left off in the previous stream was adding the handler to Warp. And let me pull up. There we go. So I was adding the handler to Warp, wiring it into the router, and then setting up my own event router. So you've got your HTTP request router, and then once that's upgraded to a WebSocket connection, then I've got a WebSocket event router that can handle events that are different types, and we have a top-level enum to kind of capture what those types are. But first, before I jump into that, I noticed something on the GitHub repository that I was working on when I pulled it up today. Here it is. This is github.com, my bconkle Rust example caster API project. If I scroll up, I just merged the work that I had finished on the last stream, where it was handling partial updates for GraphQL. So if you look in the pull requests, I had this partial update PR that I merged here, and I should not have merged it because I didn't notice that this check had failed. So this is me moving too fast on an open source project. In a production project, you want to always make sure that your builds are clean before you merge something to your main branch. So I'm going to take a look and figure out why this failed. And I already looked at it earlier, so I've got a general idea of why it failed. But I'm going into the GitHub action. So I've got a GitHub action that's building my project. And the first thing I see is just that build failed with error. So this means that the command here failed. But I'm going to need to go a little further up to see what actually went wrong. So next I see here this is the command that was run in the Docker file. So this cargo build release command here. And so going a little further up, I can see actually what the root error, or the root cause of this error is the CORM requirement. So I gave it a requirement with the uptick 0.9. And this is kind of a typical version specifier that you would see in a package.json for a Node project. So I originally came from the Python ecosystem, but then I spent a lot of time in Node and TypeScript and that kind of thing. So this is very familiar with me in Node. So the first thing that I did was I pulled up crates.io, which is the package index for the crates that the cargo tool uses. And I pulled up CORM here to try to see, okay, was there not a version 0.9? Did I miss that or something? So I'm here and I'm looking, and there is 0.9. There's a 0.9.3. So I thought that that should work. And so looking into the actual documentation, oops, that's the wrong page. Here is the documentation that I was looking into for this case. The specifying dependencies documentation, it actually works quite a bit differently than it does in Node. So this is something that I was probably too eager to see it match my expectations, and I should have taken a moment to look. So really, using it with no uptick or anything kind of matches more my expectation of what was going to happen. I was thinking, okay, 0.9 would generally be anything greater than or equal to 0.9, but less than 0.10. But that is not what happened in my case, because I added the uptick, and Cargo doesn't support that. That was one thing that I missed. It does support a tilde, which is kind of more minimal way to specify the possibility of updates here. It works a little bit different without specifying a tilde, but that was my problem here. I need to go into my project here and find the places where I used tilde 0.9 and change that to just 0.9. That's really all it needs to be. It will behave the way that I expected it to with that. And so I don't really need anything extra there. So that's my first change I'll make today. So in the handlers, going to where I left off in the last stream, this is the API app. So I've talked before about how my app is divided into two major sections. There is the apps section and the libs section. And apps generally are entry points. They're running processes. They're something that I can deploy as a Lambda function or a container running in a K8s or ECS platform or something like that. And then libs are all of the logic, all of the reusable pieces that could potentially be split across multiple entry points. It could be combined into a single entry point. There's a lot of different ways that I could use it. And so I try to keep all of the main work that's being done in my libs. And then the actual entry points are things like the API process or a worker process that's being spun up in Lambda or something like that. And so in my API here, I have my top level warp router here. And so last time, this is just a standard warp, I call it create routes, that pulls in together some different warp filters in its functional style. And I added a WebSocket block down here that continues to pass in the context with all of my injected dependencies, essentially, for working with my API, my process here. And then I also have this with auth helper here to add the subject from the JWT token if it is valid and passes the signature, the JWIC signature check. And then I said call events connections handle. So one thing I didn't change last time was I need to update this to events handler handle, because I ended up splitting it out into its own file. I can see how it's going to grow over time. So I'm going to tell it instead of connections handler, I'm going to do handler handle. And so you'll see that gets rid of the error message that it was showing there. So the actual events handler handle, that is in this events submodule up here. And so in Rust, the new style way of doing this is to first create a top level file here, which is like your librs, but for your submodule, and then pull in everything from your subfolder. So events.rs, messages.rs within that references messages.rs inside my events submodule here. So then my actual handler, we talked about before how it's handling the upgrade from WebSocket. It's spawning a thread under Tokyo, essentially. And it is then setting up some handlers to handle things that'll happen with the connection. So we've got our top level connection hash map that we're storing things in, and that's behind an RW lock synchronization mechanism so that we can keep it thread safe and still make it writable. Because Warp is an HTTP server that runs with multiple threads. And so we have to keep everything thread safe. So therefore the ARC with the RW lock. And then my handler here is once the connection is upgraded, it's registering the connection with this hash map and then allowing me to receive messages from it and send messages to it. So when a message comes in from the connection, then it's calling this route message method that I'm planning to write, but I haven't written yet. And so this route message is going to take a clone of the context with all of my injected dependencies. And then I'm going to give it the connection ID of whichever connection sent that message. So we'll know where it came from, and then the message from that it sent there. And so basically we're saying, okay, this message came from this ID, and here's some context you can use to handle that. So that's what I'm going to start out implementing now. Is I'm going to jump into this inner events router that I've created. I've got just a stub file created, but I'm going to start filling that out with what that should actually look like. So to do this, let's see. Yeah, I need to take my context, my connection ID, and my message and use an async function there. I've got another project that I've implemented this on that's in a kind of a different context. It's working with a different set of tools, but I'm going to port it over essentially to what I'm doing here. And also, feel free to talk to me in the comments. I have visibility into comments both on Twitch and on YouTube while I'm streaming here. So feel free to ask questions and I will try to answer them to the best of my ability. All right, so starting off with the router here. The first thing I'm going to set up is my route message top level function like I was talking about. So it's going to be a public async function. Since it's a public function, I need to go ahead and add a comment to it. And I'll often add the comment first because it kind of reminds me, okay, what am I trying to do here? It keeps me on task. So this is going to take WebSocket messages and route them to handlers. And I would envision these handlers, they will start out living in this file here usually, and then start making use of the things that are in the libs. But over time, they'll probably start to split up and grow. And so I would either, if I would only ever see them being in this app, if I would only ever see them living in the API app here, then I would probably split it into its own router submodule and then have a different file for each of the groups of handlers that I want in here. But I could also move them out into a lives module that's shared. And then that way, if I need to split those events between different APIs later, it really depends on the context. That doesn't always make sense. So I'm going to leave it here in my API app, and I'm going to have it take my context, which, like I said, this is my injected dependencies. And then it's going to take that connection ID, which is just going to be a reference to a string. And then it's also going to take an incoming message, which I set that up in my parent module in the last stream. So looking at that, yeah, right here it is. Incoming message has right now just the ping event, and the ping doesn't actually have any parameters to it. But later on, I'll have events that will have parameters to them so that when we're emitting this message to the handler, we can send all the details from the entry point to the handler. The idea between separating it up like that is that your entry point here, your router that's handling events, can then translate it to the internal language that your API is speaking through, REST specific types like enums that can have parameters, as opposed to the more generic JSON communication that you'll have outside of your application. So the router handlers translate those events to your internal language so that you can take advantage of the power of Rust to handle those things. But a ping doesn't actually have any details to it. It's just a plain old empty message type. And then we're going to respond with a pong there. So we talked about that in the last stream. And so in the handler here, it's going to take that incoming message. And so then let's figure out what to do with it. Not switch. I always use switch because that's the name in other languages, but it's match. I'm going to match my message. And right off the bat, it's telling me, hey, you haven't covered the ping event. So that's one of the powerful things about Rust's switch cases or match cases here is that they're exhaustive. Their pattern matching warns you if there are cases that you haven't handled yet, and that's an error, and that's really important. I think the switch cases are not really pattern matching. It really is just a switch case in Go, for example, is not exhaustive. If you forget to add cases or if you add new enum variants, essentially they're not real enums in Go, but if you add new variants, Go will not warn you that, hey, you're not handling this new case that could happen, whereas Rust does. And that reminds me of the capability of languages like Haskell or OCaml, which helps make things more deterministic. So for my ping here, I'm going to use a handler function called handle ping. I'm going to pass a reference to that arc in. I'm not going to do any cloning here. And then I'm going to pass the reference to the string in, or the connection ID string, and then the message itself. Let's see. No, in the case of the ping, the message, there's no real details for it. So I'm not going to send the message for the ping. So first off, it's telling me Arc isn't imported yet. That's just a standard library thing. Context comes from the top level crate. And then I usually group my internal dependencies together like this, crate, super, anything like that comes from this code base in this repository. I like to group them, and then anything external goes up here. Sometimes if I have a lot of dependencies, I'll separate standard library dependencies, built-ins, from third-party crates. But I usually don't have that many dependencies in a single file to do that. So this will grow. This route message here, this is essentially the router. This will grow as you have more event types. You'll handle more cases down there. And so this will get bigger and bigger as you're doing more and more eventing on your WebSocket connection. And then to actually implement that, I'm going to make this a private function. And then obviously it takes the borrowed context here, or the borrowed arc for the context, the connection ID, which was the reference to the string, and that's it. That's all we need for a ping event. So inside here, all I really want to do is send a pong back to whatever connection sent me the ping. So here, I'll just say CTX connections. So this is the struct that we built over here in this connections.rs module. So I'm going to say connections.send, and then I'm going to give it the connection ID so it knows which connection to send this message to. And then I'm going to use that enum variant for Pong to just send that, and that will automatically, Serde will translate that into the JavaScript or the JSON string that I need it to with that .into, because I created the method for it's not letting me hover. There we go. The method to translate that. I created the from trait implementation for message here. So I need to go ahead and import Pong. I'm going to just pull it. Oh yeah. I'm going to say I still want to be able to refer to incoming message itself, but then I also want to be able to refer to that enum variant also. Oh, and no. The enum variant in this case would be ping. And then the outgoing message would be Pong. So let me go ahead and add the brackets here that I need to pull the outgoing message. There we go. So now I have Pong. And then the into is calling on this trait implementation right here. So it's just using Surday to serialize the outgoing message to a string. And so essentially, because I've got it, because I'm using the surd tag equals type, basically what will come out is a JavaScript object with a property, a string property, or a string key name of type, and then a value of Pong. So it's just it's an object with a type of Pong, but there's no other properties here. I didn't put any additional details in here to give it more detail because a Pong message doesn't need any of that. So obviously, as you're building this out to do real things, you'll have more and more complicated messages that you'll encode here. So the router and then the handler here is pretty much done. It's not doing anything fancy here. So let's see what's wrong with this. I need to actually import route message now that I've created it. So yeah, I've got it added. Oh, and it also wants me to add a doc string, a comment to this because of my Clippy lints that I have set up. So I'll go ahead and give it some detail here. What is it? It's handling WebSocket connections. Yeah. So handle WebSocket connections by setting up a message handler that deserializes, that's a hard word to spell, them and determines which command to dispatch. All right. So, well, in my case, it's not really a command. It's just determines how to handle them. In my other project that I was doing this on, it was a CQRS, command and query responsibility segregation. So the command is like a mutation, and the query is like a query in GraphQL. But I'm not actually doing that here. So that's enough of a comment there. That makes the warning go away from my handle method here. But it looks like I've got warnings for quite a few other things here. So let me go ahead and type some additional detail here. I really like the Clippy rules because I tend to neglect comments and forget about them. And when you have other people working with you or coming behind you on a project, it's really important to have descriptive comments that lead the reader through what's happening because it's not always obvious based on the code, especially in a language with more syntax like Rust has. So this connections hash map here is the state of currently connected users. And I'm going to call out a little additional ID or detail here that the key of the hash map is their connection ID. And the value is a sender. It sends it's a channel that sends to or sends a warp message to the warp WebSocket message to the WebSocket connection that we've got in the hash map there. It took me way too long to spit out. So the send, that sends a message, and it's a capital M message because it's a warp WebSocket message to the given connection at the given ID. And then inserts a connection into the hash map and returns the ID. All right, and then finally, we're removing a connection from the hash map. All right, so that gets rid of those. Wow. All right, so let's take a look at this. From message, this one creates, wow, typo city today, creates a new incoming message that we set up in the right here from a warp WebSocket message. Oh, and that's a capital M message. I like to call out when things are specific types. Oh, and then Clippy likes me to also give them backticks to highlight them when this is converted to Markdown. So like when you publish on crates.io, or if you're using a documentation generator, this makes it a little easier to identify that these are actual real, like, specific words. Although in the case of WebSocket here, it doesn't really apply. Yeah, it's kind of sketchy. I might have to tune that Clippy lint a little bit. Oh yeah, and some of these just going to be backtick things like that. Yeah, I might have to reconsider that rule. I got it from another project that was using it, and I liked it, but it has too many false positives like this, because WebSocket is not the name of a type. It's the name of a technology that we're using. All right, and so this is the warp filter to handle WebSocket upgrade requests. Oh, it doesn't. Let's see what it doesn't like here. Oh, I haven't actually wired it into my warp setup here yet, have I? That's why it's complaining. So I want to use another .or, I believe. And I think I want to put this in front of the GraphQL handler. So this is how warp allows you to compose filters. So I'm composing this event handler, or upgrade really handler, alongside my filter for GraphQL events. So yeah, now that lint warning went away. All right, so we're looking clean again here. This should be all that we need to handle pings. So handle a WebSocket upgrade, establish the connection and save the connection to our hash map, and then handle incoming messages for ping and responding with Pong. So the first thing I'll do is come over here and run a cargo test, just to make sure I haven't broken anything that was working. I haven't written any specific unit tests around this yet. These are things that I could and probably should unit test, but I just haven't for this particular repository. But because of the way that I wrote it, where each is an isolated function that accepts its dependencies up front, essentially, it should be fairly easy to unit test this with a library like mockall or something like that that'll automatically generate mocks for these dependencies, so that you can test it in isolation. Oh, there is a problem here. Let's see. So it's telling me that the test's episode resolver is, oh, it doesn't have an expectation set up, which would be a mock all expectation. I haven't set up a call that matches what was called, which is kind of strange. I don't think I've changed anything around that. So, okay, it was in domains. Let's see. Libs domain shows service. There we go. So my domains, I've got it organized essentially as in a domain-driven concerns here. And so the shows service test right here. All right, so it feels kind of odd because I haven't changed anything related to this. So what I'm going to do is commit I already have a good message in there. Commit a work in progress commit first. And then I'm going to check my baseline. I'm going to go back to my main branch and make sure that everything is up to date there. And I'm going to run cargo tests there and see, okay, is this failing in the main branch too? And if it is failing in the main branch, then I know, okay, this was something that was already going on. I'm going to have to troubleshoot that separately. But it looks like, oh no, it is failing in the main branch too. So, okay, something that I did with the branch implementing partial updates previously has obviously broken this test. So I'm going to set this aside. In an actual production scenario where you're working on an app that's got a deadline, you want to triage. You want to look at this and think, okay, is this related to what I'm trying to accomplish right now? And make sure that it's not going to distract you from a goal if it's not completely necessary. Now, in this case, a failing unit test is going to block people's builds. And so I probably would go ahead and set aside what I was trying to accomplish with WebSockets and debug this unrelated issue that was coming from the main branch. But for the purpose of the stream right now, I'm going to go ahead and go back to what I was doing for the WebSockets because it's not really going to affect what's happening here. I should be able to complete what I was working on with the WebSockets without having to fix this unrelated resolver problem. So let me get back to, what was the branch name? I've got to scroll up and look. It was temp stream. That's right. Very descriptive. All right. So from here, everything else was passing though that I expected to be passing. So I'm going to move on for now. What I really want to do is get an integration test in to check in a more realistic scenario how this works. And so this is typically how I'll approach things. I will often do the integration test first. And I set up my integration test stack to make sure that it's easy to run, to make sure that it's something that I can do over and over again locally without having to go through a lot of effort. And then I also want it to be something that is run in my CI process in a really easy, fast way that doesn't rely on deployed dependencies, that can't conflict with other people who are using an instance or something like that. So I'll typically, when deploying on AWS, I will use local stack to abstract away a lot of that. I'll have Lambda functions, S3 buckets, Kinesis streams, triggers that will allow Lambda functions based on DynamoDB, table operations, all kinds of those kind of things. You can all do locally with local stack, and then also run in a Docker Compose formation inside your CI process. And so I have integration tests set up so that they will run on every commit inside that Docker Compose formation in CI, so that they're cheap and easy and they can validate things. So those are often what I'll write first, is those more realistic integration tests. It's not fully end-to-end. You don't have a front-end application integrated to all of it, but it's deep enough that you'll be able to see where things don't fit together the way that you expected. And then once I've settled on an API that is essentially what I'm looking for, I then will move in with the unit tests, because the unit tests are more fragile. They break more easily, and they often break on things that aren't really problems. They're just things where you need to update the unit tests. And so if you're iterating quickly and changing the surface area of your API quickly, it's usually better to hold off on unit tests until you get to a good place with your integration test, at least in the way that I've approached things. So my integration tests are kept in apps API tests. So the tests folder in any package, wow, that kind of glitched out as I was dragging it over. But the tests folder, the integration testing folder, is a special folder in a Rust crate where it will test by creating a de facto or on-the-fly module or crate or package, or I guess basically an isolated environment where this test file is like a main.rs file. This is what gets executed with all the tests that are inside it. And so you're using your dependencies that you're testing just like you would use them externally, just as if you had pulled it in on as a crate from Cargo, and gives you that isolation where you're using only the public exports of your module in a realistic way. So I like that feature. So everything in this tests folder is working that way. But I also have a test utils that gives me things like running my server by using Tokyo Spawn, gives me some test utils for doing things that I need to stage data or prepare things for integration testing. Doing things like creating things together, a user and a profile together, a show and an episode together, just aliases to make certain very common operations in my integration test faster. So this is also the best place for me to put some utilities for testing my WebSocket connections. So I'm going to add to my test utils struct here a couple of things that help me integration test my WebSockets. And so let's see. Yeah, the first thing that I want to do is, come down here. My scroll wheel is way too sensitive on this machine. I typically code on a Windows machine with WSL2, but I also use Mac OS and Ubuntu Linux pretty regularly. So I'm switching back and forth between operating systems a lot. The first message that I'm going to do is going to be kind of a general purpose underlying method. And then I'll add a couple of convenience wrappers around this method. But I want it to support a timeout. I want it to be able to say, okay, send this to WebSocket and then wait for a certain amount of time to pass. And we're wanting the connection to, let me see, let me double check and make sure that I'm reading that right. It's been a little while since I've worked on this. Okay, yeah, we've got the WebSocket connection, sending the message to it. And then we're seeing what completes first is this check. So this toFuture is kind of the check that we're going to run. Oh, and I'm not showing the screen that has this on it. Okay, yeah, I'll go ahead and just start writing it here. So, all right, my send to WebSocket method here is going to take a generic T type in. So this is going to be whatever I'm send, or this is actually, no, this is going to be the future, what the future returns. So the way that I want to use it is just passing in an async function that will check the result of the WebSocket. So, or the message that was sent. So it's going to be off of an instance of itself here. Let's see, it's going to take the WebSocket message. Let's see. Yeah, this is going to be the message that I'm going to send. And then I'm going to use toFuture to read the response from the server. Okay, yeah, I've got it all sorted out in my head now. That's right. So yeah, the message that's coming in is what gets sent. And then the toFuture here is going to be checking the response that comes back from the server. So the message is going to be a ping. That's my incoming message that I'm sending to the server. And then the toFuture is going to check that pong is sent back. So I'm going to say that this is going to be an inline function or a Lambda function that takes a split stream. So this is part of the future stack, the channels that we're already using to work with WebSockets. All right. And like I said, I've already done this on a different project. And so I figured this out iteratively there. And I'm kind of copying over some of what I did there into this new context. So this is a split stream. So that means it has a TX and an RX, a sender and a receiver. It's specifically a WebSocket split stream that uses TLS for security, for encryption, and then it's a TCP stream because it's coming in off of an HTTP connection. So yeah, that's a lot there. And then it's going to return that T. So it's going to return a future that we can await inside here. And then the timer is going to be the timeout, essentially. How long do I want to wait for the response to come back from the server to my ping, or for my ping? All right, and so it's going to return just a plain result for a unit, which means it doesn't actually yield anything. It just waits for it to finish. And then I'm going to add a type constraints to my T. I'm going to say that T can be any kind of future. All right, so got my signature ready here. I've got some types that I need to import. So I'm going to import the warp message, going to import the WebSocket stream. Oh, I might have to install some new dependencies for some of this. So there were two things. Was it Futures Util? I think was one. Yeah, Futures Util and Tokyo Tungstenite. So I'm not using Tokyo Tungstenite yet, but Tungstenite is a WebSocket client implemented in the Tokyo Async model for Rust. And so that's going to be how we're actually talking to our server that's running a WebSocket host in another thread. So, okay. I need to go down here to my cargo and I need to pass in a couple new dependencies here. Underneath futures, I'm going to add futures util. Give it the sync and standard features, feature flags. And then I'm also going to add Tokyo Tungstenite down here, which is the WebSocket client. So it is already pulling those in. You can see at the bottom there, VS Code is pulling those dependencies in. And then I should be able to now find the WebSocket stream I was looking for from Tungstenite. And there I can pull the maybe TLS stream in. What did I? Oh. There's that. And then TCP stream. I think I used the Tokyo one. Let me double check that. Yeah, definitely the Tokyo one, which makes sense because we're doing everything inside the Tokyo async model here. So, okay, I've got my dependency satisfied there. Future, I think that's the one that comes from futures util. All right, so body of my function here, the first thing that's going to do is set up the URL by parsing it. So I'm going to use URL parse. And I'm also going to format it with the format macro. Say, okay, it's a local host. First, or the parameter that I'm going to format in is the port, and it's going to be /events. So that /events comes from the warp filter that I set up here in the router. You can see warp path events. That's what gives me the /events here. And then let's see. The port is going to come from this test utils instance here. You can see it has, oh, it doesn't yet. I'm going to need to add the socket adder on this to use down here. So let me go ahead and wire that in first. So self adder. So that's what I need to add is the adder. And then that's where I'll pull the port out of. And then before this will be happy, I need to add the question mark. So if you haven't seen the question mark in Rust, this is translating the result that comes back to the inner type that the result is wrapping. If the result is okay, if it's an error, then it just immediately returns the error as the result for this method here. So it like bubbles the error up and halts execution on the function, all in a nice syntax, all with some nice syntactic sugar there. But it's still going to be upset because I need to give it the okay for this result right there. There we go. All right, I need to use the URL. Oh, now where does the URL come from? This must be another dependency that I haven't added. I thought I had that dependency, but maybe I don't. Yep, I sure don't. So in my dev dependencies, because I'm only going to need it in the integration test here, I'm going to add the URL library at version 2. There, now that's happy with that. So now it's complaining about the adder that I haven't added yet. So I'm going to add it to my dependency here, but we'll also have to figure out where it comes from. So let's see. All right, socket adder comes from just the standard library. Okay, I was curious about that. All right, so I need to add it down here, and then I think I'm already generating it right here. Yeah, so really I just need to pass it in now. And I'm done using it inside here, so I can transfer ownership to the test utils. So I'm not using a borrow or anything like that. So the test util struct now owns the adder, and then I'm calling the adder to get the port there. So, okay, now I have my URL and it's in an actual parsed URL format here. So now I'm going to pull out, or I'm going to connect connect to the WebSocket server that I have running in another thread within my test process here. So like I was saying, this init method on my test utils launches it as a new thread in a new Tokyo thread with Tokyo spawn. And so then from within the test process, I will be establishing a WebSocket connection to my server and making calls to it for my integration tests. So the first thing I'll pull out, let's see, what is this first? It's connect async, which comes from Tokyo Tungstenite. And I'm going to tell it to connect to this URL that we just parsed. This is an async function, so I'm going to await for it. And then since we're in a test right now, I'm just going to use expect. And so this will panic if it doesn't actually unwrap the result here. Is it a result? Yeah. So it'll just error out if it's not able to unwrap the result. And so this returns a tuple with the WebSocket stream and something else that I don't care about. What is the something else? Oh, the response, which I really don't care about. I do want that WebSocket stream though. And then I'm going to pull out the TX and RX, the read and the write from the stream. So I'm going to say get a mutual or a mutable reference to write, and then I only need a immutable reference to read. And then this is going to call the split method. And it doesn't like that yet, but I think I have to import a trait in order for it to recognize it. So let me see if I can remember what the trait is here. I think it's under futures util. I think it's, yeah, instead of using future stream, I use it under future util. Let's see if that does it. No. Oh no, that is right. I just need to show which submodule it's in. There we go. So now I've got the split stream. That's a struct though. That's not a trait. So that is not satisfying that split requirement there. So I've got to remember, okay, where does the split come from? Maybe it's the stream extensions from futures util. There it was. Yeah, so stream X from futures util is where that split method is supposed to come from. So now you'll see the split method show up on here. And then I've got my writer and my reader. All right, so with that, I can now send the message that I want to send in my integration test. And then I can just call unwrap on it. Like I said, this is a test, so it doesn't matter as much, but I would not do this on a production project. I would handle that result by converting it to an HTTP error or something like that. And I would report it to whatever error reporting service that I'm looking at. But once again, you see it's complaining, and I think it's because I also need the sync extensions from futures util. Was that it? Yes, that was it. But it doesn't like the message here. So let's see. Oh, I'm using the wrong message. I'm using warp message, but this is actually the tungstenite message because it needs to go through that tungstenite REST client library. So there's message. I'll pull that out of warp, and then that actually belongs here in the tungstenite import. Maybe it's not specifically that. Let's let autocomplete save the day here. There we go. Yeah, it was under tungstenite message. There we go. All right, so now it has the send method that we were looking for. It sends the message that I pass in, and then let's see, from there, all right, so we're gonna use the timeout feature from Tokyo. We're gonna say duration comes from the milliseconds that were passed in here. And then I'm going to default to 1,000, so 1 second. And then it also needs a future here to set the time up for, or timeout for. So the future here is going to come from that toFuture function that was passed in. So this is essentially a callback. This allows me to craft my expectation from the integration test outwardly that is making use of this utility. So I'm going to call the toFuture with the reader. So as you can see, I'm passing that stream in. And then I'm going to say, okay, await that. And then I need to turn this into an if statement because I want to check and just see, okay, did it actually finish or did it error? And then this, whatever's happening in the toFuture will carry my test expectation. So I just care about whether it actually completed or not. So I'm going to make it an if. I'm going to do the await, and then I'm going to call is error. So I'm going to see, was it an error? Was it not an error? And if it was an error, then I'm going to go ahead and manually use the panic macro here to say that the future timed out. So this means that the timeout failed. It could also mean that toFuture returned an error. So I probably want to handle that case later, but I'm just going to do the plain timeout here for now. All right, so I've got my send to WebSocket kind of underlying function here. I'm going to add a couple of quick helpers, basically to make passing a timer or a timeout value optional. So I'm going to start off with send message with timeout. So this is for when you definitely want to put a custom timeout in. So it's going to be receive a reference to the instance of the test utils it's acting on. And then it's going to carry the other dependencies that we need for the underlying private function that I'm calling here. And then it's also going to take a timer value for when the timeout should happen, calling it timer rather than timeout because the utility from Tokyo is also called timeout. So the result here is also going to be a unit. And then I'm also going to have that same constraint on where future. And then really all this is doing is it's calling the underlying send to WebSocket with the timer as a sum. And then since it's an async function, I call await there. And then I'll do the same thing, but without the timeout for when I just want to use the default of 1 second and I don't want to go to all the trouble of actually passing the none in. But yes, and this is just send a message. All right, so I've got my test utils here. I'm ready to connect to my WebSocket instance. I've noticed that my other modules here have gone. Oh, okay. So what's happened here is I added a new property to test utils. And so it's telling me here in these other integration tests that I've already written that I'm destructuring here, but I'm not destructuring all the properties here. So to get rid of that message, I just need to add the dot dot. That dot dot makes it really explicit that, hey, there's more fields here that you haven't destructured. You might be forgetting something, or you might need to handle something new. And so, like I've said before, I think this is the power of Rust, the fact that it recognizes this, it makes you deal with this and say, okay, yeah, there's a new property there. I don't need it though. Dot dot just means let me move on. So I'm going to fix that in each of my places that are using it because I don't actually need to pull the socket address out for any reason inside the tests, but this makes it explicit. And that really lines up with the Zen of Python. Explicit is better than implicit. That I definitely really appreciate for a lot of reasons. All right, we've got one other module that we need to add the dot dots to. These are all the different entities that I'm making HTTP calls to test in my integration testing stack that runs against the Docker formation that in this case just has Postgres, but in other cases might have local stack or something like that in it as well, or a Redis server. Basically trying to avoid any deployed resources for your shallow integration tests. All right, so it doesn't like that I haven't put comments on here. So I'll tell it that one's sending a message with the default timeout. This one is sending a message with a custom timeout. All right, so now I need to create, whoops, not a folder. Did it actually create the folder? I can't see where it went. Maybe hitting escape made it stop. All right. So I'm going to tell it test events. Oh, yeah. And I like to use a naming convention so that I can always identify which ones are my integration tests. So I'm going to call it test events. And then in it, it's going to be pretty simple, but it's going to make use of my utils that I was using. So this is going to be async function test ping. And it's going to just have a unit result. That means I can return an error and the Tokyo test runner will report on the error, or I can just return an OK unit and like this at the end, and everything's fine. Not sure what it's not liking about the syntax yet. Oh, because result typically will take two cases, but I typically like to use the anyhow result that just uses a any error as the error type there. So any error that conforms to the anyhow trait essentially can be returned from this type of result. So it's a more general result type. Cuts down on the typing. So the first thing I'm going to do is instantiate my test utils. I'll need to import them, and I don't know why it's not automatically doing that for me, but maybe after I save. Yeah. All right. Well, oh, that's right. So since this is in the tests folder and is treated like an integration test by Cargo, I actually need to define test utils as a mod and then use it. There we go. So then, yes, now there's my utils that I pulled out. And then let's construct my ping message. So I'm going to use Serde for that. Serde JSON to string. Serde is just serialization or deserialization to JSON or other formats like YAML or what have you. Say, okay, convert this ping type to a JSON. So that will be a JSON object with type of ping. And with my utils, I'm going to call that send message utility that I just set up. I'm going to call it just with the default timeout of 1 second. And so my message here is a string. So I need to use a little helper from Tungstenite saying that I want to send a text message. So that's how I'm going to wrap it with the text enum so that Tungstenite knows that I'm sending text. And then my to future here is going to be an inline function. And then it's going to return, let's see, let me go ahead and stick the await and the question mark at the end here to collapse that down. Yeah, okay. So it's saying that what I returned here is not a promise, which makes sense. And so what I'm going to do is I'm going to take that read variable. And so this read is that split stream that I'm passing in, and I'm going to call take. So I'm going to say for every one event, you could use this for batching by saying for every 5, take 5 or something like that. But for me, I'm going to just do one for each message that is sent in. And then for this, I'm going to pass it an async function. Read take for each that already returns a future. But then for my handler for each, that one needs to be an async function that the take method there will actually wait for. And I think this is in Tungstenite where this is all implemented. I'm going to say the data should be taken by unwrapping the message. Again, this is just a test, so I'm using things like unwrap and expect where I normally wouldn't in production code. But and I think I need to pull in a trait to get take to work. And I need to move my dependencies. We need to group my dependencies around like I like them. There we go. All right, so the trait that I'm looking for is here's util stream ext. That was the trait that I pulled in the other spot. Yep, and now take is working. So my data is just a slice, a vec of Unicode, of byte data, essentially. So I'm going to I'm going to create a string from that byte data from UTF-8. And then I'm going to I'm going to let it borrow the data. And then again, calling unwrap because this is just a test. Oh, I forgot the equal sign there. All right, so. Oh, I need to import standard string. Actually, you know what? I can just make this a fully qualified. It's only a few more characters. So yeah, standard string from UTF-8. So my result comes back as a reference to a string. It's a borrowed string. So next, let me set up my expectation here. This is what it should be. So again, I'm going to use surd, and I'm going to tell it to create that Pong object for us. So it's just the object with type that equals Pong. So that comes from outgoing message, which I'm going to need to import. I'm going to need to type the word string correctly. And then again, I'm going to unwrap the result here. And so what we get is this expected string. So now all that's left is the assert. All right, so I've got my test put together here. I need 2 more things before this will work, though. The first thing that I need is the Tokyo test directive up here. That tells Tokyo that, hey, this is an async test that you need to run. But then also, since this is relying on some resources that are running in a Docker container, I'm going to also tell it ignore. So with the ignore feature in Rust tests, you can separate your tests into 2 levels, essentially. You can have the unit level tests that don't require any kind of external dependencies, no Docker compose formation running inside your CI server or anything like that. So those tests, those unit tests, are not ignored, but then I ignore my tests that are integration tests that do rely on that Docker compose formation running. So you can tell Rust to run units by just running it by default, and then you can tell it to run integration tests essentially by running the ignored tests. And so that way you can separate them into 2 levels. And then typically I would pair that with a full end-to-end test of critical paths with a front-end client integrated with it. But in my case here, I don't have one yet, so the integration test will be as deep as I go with it. All right, so it's trying to say that these still aren't used, which I don't understand because I'm using it right here. Maybe that's not what it's saying? No, it's saying that it's never used. I've never seen the dead code detection be wrong like this before. So I'm wondering, what did I do wrong? There's got to be something I'm doing, right? Oh, I know what it is. The reason this is happening is that there are other tests here that are not using it. And each one of these tests in the test folder, since it's considered by REST to be an integration test, it is considering that as its own module or its own, maybe its own crate. I can't remember which one, but it sets it up with its own isolated environment. So test utils is obviously being loaded with one of the modules that doesn't use it, and that's triggering the unused or dead code flag here. So it's not really useful in this case. These are just test utils. So I'm going to go ahead and add a directive to the top here that tells it to ignore dead code in this file because it's a special case. So this allow dead code allows me to skip that Clippy warning in this case. So yeah, now everything looks peachy. All right. So I'm going to come back over here to my terminal. Yeah, let's go ahead and try running the integration tests. This is the first time I've done this in this project. I will give a disclaimer. It probably won't work, but let's see what happens. So to run integration tests, I'm using this tool called cargo make. And so that gives you, in addition to the cargo.toml, it gives you a makefile.toml. And this makefile is workspaces aware. So it's aware of, you'll see I'm disabling in a lot of cases because I only want it to run once, but you can set up tasks that are aware and run once for each workspace or things like that. It also makes it easy to pass in like wildcard arguments like this. So you can allow it to feed it with all the arguments after a particular point, which make files don't. It's much harder to do that in make files in my experience. Anyway, this cargo make has an integration task here. And so the integration task is using a run mode of test. Run mode is just like an environment specifier of, okay, test or CI or staging or prod, something like that. I'm telling it to select the info log level and then also the SQLX query at the warn log level because I want to see what SQL is trying to tell me during these tests. I've got it set down to single threaded because in my case, some of my tests could step on each other. Generally, you want to avoid that though. If you can write your tests so that they're isolated and you can have concurrent tests running that don't step on each other, that's a much better thing to do. So this is a cop out and you probably shouldn't do it, but I did it to save time in this project. And then I'm also saying, don't give me a full backtrace in this case. So then it's running cargo tests, no capture, which allows my standard output to come through. Otherwise, it suppresses the standard output so that you've got clean CI results. So I really should take no capture out of the integration CI command that runs in my GitHub action. But I'm leaving it in for now just in case I need to debug some things. It's not very verbose yet. It will be. And then the dot or the dash dash ignored is what's telling me, okay, run those ignored integration tests, those ones that require these this external structure, this Docker Compose formation to be running in the background, whether it's on your local machine or out in your CI pipeline. So I'm realizing I'm probably not running Docker yet. Yeah, I haven't started it up yet on this machine. So I've got to fire it up in the background, and I've actually got to start up the containers in the background. And this is probably a good point to take a break while it's setting up the Docker Compose stack here. But okay, I'll go ahead and kick it off first. Trying to remember the command. It's cargo make docker up -d. That's right. Oh, it's already, it automatically restarted my containers that I had running last time. That makes sense. So that makes it so much easier. I don't have to take a break and let those build. Let me just run cargo make integration right now, and we can see most likely the failure that will ensue because I've forgotten something. Or this rogue unit test here coming back to bite us somehow. I'm not sure. This reminds me of the unit test failure we had on the other on the stream previously, and maybe I didn't actually resolve it in this branch. In fact, I'm almost sure that's what happened. I hadn't actually resolved it in this branch yet. All right, so you can see the standard HTTP integration test is running through. What this test events test for ping is going to do is it's going to establish a WebSocket connection through the standard upgrade process, and then it's going to send a message and then wait 1 second for the server to send back the pong. So I could have just isolated it down to test ping, and I'll probably do that if I have to rerun it. But I wanted to make sure everything else is working too, and that I didn't break something along the way. And oh wow, yeah, it finished all of them. So let me look for ping. There it is, test ping passed. So if we change this to something else, one thing that's really important when you have a test that you've just written, it's always good to see it fail too. If you can make sure that it's failing, then you can usually guard against a false positive. And so instead of the pong, I'm going to say, let's expect just an empty object, which is not what we're going to see. And so what should happen here is we should get a failure now of that test. So I'm going to go ahead and add test ping at the end of my cargo make integration command. That uses the pass-through arguments that I was showing off from cargo make to isolate it down to just test ping. Oh, it doesn't like that I took outgoing message out, but it'll still run the test. And boom, there we go. We can see it did fail as we were expecting. It was looking for an object with a type pong, but it just got this empty thing here. So now let me fix the expectation and run it one more time. And we should be good. We should have our WebSocket server up and running. It's handling commands. We're now integration testing it both on our local machine, and we can run this out in CI and get an idea of how things are working. As your sequences get a little bit more complicated, this strategy that I've got of just waiting 1 second, you might have to get a little more sophisticated with that. There are probably cases where you'll have messages that you'll send that you won't expect an immediate response on to. And so your test will evolve and become more complicated over time. But this helps you validate just that baseline functionality that, hey, I'm handling the upgrade request. I'm handling the incoming ping message. I'm sending a pong back. So this gives you confidence that things are actually fitting together the way that you expect them to. And yeah. All right, that was the main thing that I wanted to accomplish on the stream tonight. I'm trying to think through. I also solved the build problem that was coming through there. Thinking through, okay, what else should I cover, if anything? Yeah, I think that's probably what I'll cover for tonight. So in the next stream, I'm going to start stepping into deployment most likely because I've got my WebSocket connection here. I think on the TypeScript implementation of my API, I probably had more than just the ping event. So I might implement that too. And let me pull that up and see. So on Rust example caster API, let's see. All right. Yeah, I'll look into that later and try to find what I was thinking about there. Um, yeah. Okay. It really has escaped my mind. So that's probably a signal that it's time to end the stream, that I'm winding down and getting tired. But thank you for hanging out with me and working through adding WebSockets here. Oh, yeah. I remember what I was going to look for. I can look for that really quick. It was just to see if I had, and not in the Rust one, in the TypeScript one, if I had some um, other events besides just the ping. There we go. Nest.js caster API. Um, look for ping. Yep. Okay. Event types. Oh, I did. I had. Yeah. Okay. I was moving into the Redis channels. Okay, so actually that would be a really good thing to cover on the next stream, because the approach that I'm showing right now, just managing the connections for your single instance, doesn't work in a horizontally scaled deployment where you have multiple instances that are running. And so really using something pub sub like the Redis channels is a great way to communicate between those processes. So I'll finish that up. I'll go ahead and do an approach on this. I haven't actually worked with Redis in Rust yet, so this might take a little bit of doing to get together. But it is an important part of a realistic implementation of this type of communication. So this is going to be like in my hypothetical podcaster app, it's going to be a chat stream, a private chat between the participants of the show that's being broadcast. And so that's what the goal was here, was the Redis channel would be the channel that I could publish messages to, that then other horizontally scaled instances of my API could then pick up on and broadcast to its subscribers, its connections that were upgraded. So yeah, that's probably a good thing to move into in the next stream. That might take me a little bit to prepare for it. But also coming up tomorrow, tomorrow midday, um, after my stand up, I'm going to join Alex Kaliris for the Rust review episode that's been put off a little bit. I've had vacation and family health stuff come up, and so it's slowed things down a little bit, but I should finally be able to get to it tomorrow. Alex will join me and we'll go over 9 or 10 articles from the Rust community and talk about what we thought about them. And so I'll look forward to seeing people there tomorrow. Thank you very much for joining me today. And I hope you have a great night.